Let's review the topics which we covered in lecture 1-2 by going through some practice questions, such as describe the two ways to include comments in a C++ program. I think we have discussed that we can include a single line comment by a double /, or we can use a C language type comment using /*, and we can have a multiple line comment over that and then end that comment with a star and a /. So if we, one way to use the standard is C style comment, and another one is a C++ style comment, and you can have multiple line comments. And for if you are using this kind of comment, if you want to insert comment in your program like this, then you have to put these double / before each line. In this question, it is being asked that what is wrong with this program. So let's go through this one by one. It has include preprocessor directives, the integer main function. A main function is returning integer, and it's a void in here. It's starting and ending curly brackets are here, and we have a comment, so we can just write anything over here. And we see that cout with an output operator hello world. So but it's missing the semicolon over here. That means the compiler will not run this. It will throw up a compile time error saying that the semicolon is missing over here, and that's the answer. The semicolon is missing from the last statement. Here it is being asked what is wrong with the following C style comment. So if you want to include this comment over here, since we haven't used any since we have used a comment type thing over here, since starting of the comment, end of comment, but it is being enclosed in the double quotes, so whole of this sentence or all of these bunch of characters would be taken as string literal, and this string literal would be printed just like it is being displayed on the screen. Every string between the double quotes will be printed, including the intended comment, just like as we have typed in between these two double quotes. What is wrong with this program? Let's start from here. We say that include IOStream, but we have put a semicolon. This is an error. The preprocessor directives are supposed to be defined before the start of the program at the very first, and each preprocessor directive is supposed to be in the separate line but without the semicolon. So the semicolon is an error. Integer main, but main is a function, it must include the round brackets. The sign that some keyword is acting as a function, we must include round brackets, so they are missing, so that's another error. And the comment, you can just put anything over here, and we say n equals to 22, but we haven't declared n equals to, we haven't declared what type of n is, so we should declare integer n and then we should initialize it. Here it will say that n is unknown or not visible or something like that. Then here it is say cout operator and double quotes, but we haven't closed the double quotes. That means this is not a complete string literal. A string literal, or the if you want to include more than one characters in the output stream, or you want to display them in the output, then you must enclose them in double quotes, starting double quotes and ending double quotes. There are 4 errors. The precompiler directive on the first line should not end with a semicolon. The parentheses are missing, and is not declared, and the quotation mark on the last line has no closing quotation mark. What does the declaration do? Simple question. A declaration tells the compiler the name and type of the variable being declared. It may also be initialized in the declaration, just as we can write n equals to since I think we wrote something like integer, sorry for bad writing, integer n equals to 2. So this line actually does is its declaration of variable n, and we are also initializing the value of n to 2, and we are saying that the type of this n is integer. That means 4-byte memory space has now been allocated in the memory space in which the program is running, and its type is obviously integer and integers, and since we have written the type of this object or this variable n is essentially a symbol representing an integer type object. This int says that what values are allowed in n, n will only contain whole numbers, and what operations can be done on n. What is the purpose of pre-processing directives such as include IOStream or any other header file? It includes contents of the header file IOStream into the source code. That means that whatever is written in the IOStream header file is automatically included in the source code, since we have included that header file. So does this include declarations needed for input and output, such as the output operator and so on and so forth? What is the shortest possible C++ program? I mean, it should not do anything really. So you just have empty curly brackets, integer main, and obviously it's supposed to be if you want to include IOStream and so all that, but we haven't used any cout or any output operator, so we don't need to do that. If you just write integer main and just empty parentheses, curly parentheses, it will be a shortest possible program, but it's not doing anything. What's wrong with these declarations? Integer first equals to 22, that's okay, comma last, and we are also initializing those. Last equals to 99, new equals to 44, and old equals to 66. I mean, on the surface it looks like they are okay, but actually it might be possible that there could be a word or maybe words here which are the reserved keywords of the C++ language. I mean, I'm going to see those reserved keywords in a moment after we are done with these practice questions, but we cannot name our variables the same as reserved keywords. So only thing wrong with these declarations is that the new is a keyword. Keywords are reserved and cannot be used for names of variables. So if you want to declare and if you want to use those variables, you have to keep in mind their naming rules. That variable name must start with a letter or maybe an underscore. They can contain letter, numbers, and underscore character only. Uppercase and lowercase are distinct, since we have talked about that in the section 1, that C++ is case sensitive. Name should not be a reserved keyword, just as in the previous slide, in which the new keyword was used as a name of a variable, which is not allowed. Some good examples: salary, new name, my value, but keep in mind that this my value, I mean this my value and this my value are two separate variables. I mean, it's not suggested you use upper and lower case letters for the variables name. Use really distinct variable names so as to not cause any confusion after I mean, whenever the program runs or whenever you're writing the code, I mean, it will not cause confusion for the compiler, because it will treat these two variables as two separate variables, but it might cause confusion for the programmer. He or she might mix it up that these are two same variables, but they are not. These are two separate distinct variables because it contains capital M and it contains a small m. Some bad examples: I mean, this thing is obviously not going to work because it's starting with a number. This contains a space bar. This contains a dash but not an underscore. Underscores are allowed, so as here. Class, once again, reserved keyword. Struct is also a reserved keyword, and while is also a reserved keyword. So it's suggested that you use the names of the variables or objects which are self-explanatory and not use the reserved keywords. I'm going to display the reserved keyword file. I'm going to upload that in your class folder. You can see that it's not a complete file really. It will give you a ballpark idea of what the reserved keywords are and not use them as your variable or object names. Okay, parse the following program, identifying all the keywords, identifiers, operators, literals, punctuation, and comments. So parse means resolve a sentence into its component parts and describe their syntactic roles, or in computing, an act of parsing a string or a text. That means that the compiler is going to probably ignore the empty spaces. It's only going to see the keywords, identifiers, operators, literals, punctuation, and it's not going to see the comments as well. It will only going to see the keywords, identifiers, operators, literals, and punctuation, and then it will do what it's supposed to do, translate whatever you have written as a software code into something which the computer can understand, which is its machine code. So the keyword is int, the identifiers are main, and c and cout. Essentially, main is actually a function and is the object name, or of type integer. Cn and cr are also string modifiers, and nl is used to flush the output buffer and insert a new line character. So it does two things. Operators are the round parentheses, and the insertions and are insertion operators, and this thing star equals to, and these sorry, operators are these parentheses and these input and output operators, and this thing is actually equal to, I'm going to discuss that in probably in this lecture or next, that what this thing actually does is it says that n multiply equals to 3 and will be taken from the user, whatever the user types as the input, and it would be assigned to n. Let's say the user has input, for example, 10, and I press enter after that. So n is a 10, the value of 10 is assigned to n, and we have written n multiply equals to 3. Actually this line means n equals to n multiply by 3. So if the value of n is 10, that means this value of 10 is here. 10 into 3, this expression is evaluated, and the resultant value of this expression is 30, and now it is assigned to n using these single equals to sign, which is the assignment operator. The literals are 3 and n equals to, so this thing is essentially a character, and actually is behind the scenes actually a number, and n equals to is essentially a string literal, because we have displayed a string over here. Punctuation symbols are opening and closing curly brackets and a semicolon sign, and the comment is the whole line preceded by these double forward slashes. Identify and correct the error in each of the following. In part A, cout, actually cout will not use this input operator, it will use the output operator. So whatever is here, it should be outputted to the console output. So this thing is wrong. Integer double equals to 44. Once again, double is a reserved keyword. You can just use any integer. X equals to 44. You cannot use the reserved keyword as variable names. In part A, the output object cout requires the output operator. It shouldn't be cout and this count. The word double is a keyword, and in C++ it cannot be used as a variable name. You can use integer d equals to 44 or any other letter for that. This is the standard C++ keywords. I will upload this file to your class folder, and these keywords are not to be used for variable or object names. Some keywords we are going to use, such as and, but we probably would be using these essentially a synonym for the and operator, and it's a logical operator which is essentially logical multiplication. I'm going to see that in some future lecture. Then we have some bitwise operators. There are many of them. Once again, boolean type, it is actually a sense integers. It's actually a special kind of integer. It can only contain values 0 and 1 or false or true. Break, it is used to break a loop or terminate a switch statement. Going to use that. You do not need to learn all of these keywords as we go along in this course. You will learn when you are practicing writing the code. The best way to learn this language and this course is, since I am typing all the codes right in front of you, you should also type with me while attending the lecture. I mean, you have to sit in on the computer and type the code in code blocks integrated development environment and keep on practicing the typing. So once you understand how to type the code and how the code behaves, then you have a good feeling to and you will develop a good feeling how to develop good software programs. Case is used for switch statement, and character, once again, used to declare type and a variable or object of type character. Class, we are going to use that. It specifies the class declaration. and it's a bitwise operator. Constant definition, we have used that, and whenever we use the constant specifier, those constants can be used by their names, and the compiler inserts the value of those constants wherever the names of those constants are used. um, Continue means jumps to next iteration of the loop. If we have some logical condition and we want to continue if that condition is true. Default is the otherwise case. Whenever some, I'm going to discuss that when we discuss the switch statement. Whenever all the conditions are not true, then the default condition runs if it's specified. Delete deallocates memory allocated by the new statement. New creates an object and it allocates a memory and returns actually an address of that. I'm going to discuss that. Don't freak out if some words sound really alien, but these are essentially keywords. We are going to do these or learn these keywords, how they behave in whenever we are developing our programs. Do is used for do while loop. It's going to be really simple with that. Double is a double precision floating point, and else is used with if else. Enum is going to be used in this, I'll bring you next lecture. Used to declare an enumeration type. You can use something like enumeration type of, let's say, semester. We have 3 semester, obviously not in this year, but let's say we have 3 semesters. Start of the year is the fall semester, then the spring semester, and then the summer semester. So we can just declare our own types, and actually it's a precursor to structures. Explicit used to prevent a constructor from being invoked implicitly. I'm not so sure whether we are going to go that far in object-oriented programming, but let's see. Then we have false, one of the 2 literals for bool type. One other one is true, obviously. Float, once again, to use a floating type object is used to store a decimal number. For it's a loop. Whenever we want to run some code multiple times, we're going to use the for loop. It's a keyword. Friend, so specify friend function in class is used in object-oriented programming. Goto, do not use goto keyword because goto will make your code look like for lack of a better word, look like spaghetti code. It can go from anywhere to anywhere. If you have learned basic and you have used goto a lot, do not use goto in C or C++ programs, even though the facility is there, but it's strongly recommended not to use this goto statement. If to check for logical checks, inline, I'm going to use that really, but somehow it might be used later. Integer type integer, if you want to declare a variable. Long integer type, it uses a larger memory space to store even larger integer, or maybe long double as well. It will probably be 16-byte floating point number. Going to see that in a future lecture what this long keyword does. Mutable, well, not going to use that. Namespace allows the identification of scope of blocks. I mean, namespace contains the names of the objects or the variables which are unique to those namespaces, and they are preceded. Just we have discussed that all the telephone numbers in this country are prefixed by 92 whenever someone is dialing from outside. That means the numbers are unique internationally if they are prefixed with 92. Similarly, if multiple software teams or multiple programmer teams are working together to make a software, it will be really difficult to assign separate variable names to each of those programmer teams. So what we can do is we can assign them separate namespaces, so that whenever one programmer team is free to use any variable name, provided it's not being in conflict with each other in their own namespace, so they can use their own variable names, and the other software programmer team can use their own variables names, and those names could be same, but we are going to differentiate, or we are going to distinguish between these two names using the namespace suffix or namespace prefix, sorry. So that means that, let's say we have one namespace, and one namespace is let's draw a picture. Let's say we have one programmer team, let's call programmer team A, and it has a namespace, and we just call that namespace A, and they have used the variables integer A and B. let's say we have another programming team. Usually large software programs, they contain millions of lines of code, and they are developed by hundreds and maybe thousands of programmers. And usually big companies, they have multiple programming teams all over the world, and they are usually located in different countries to get the benefit of different time zones. So the first programming team online would be in Far East, where the sun rises the earliest, such as in Japan, New Zealand, and countries like that. And then it will be somewhere around Malaysia, Singapore, and then the programmer teams would be in maybe in Pakistan, India, and then it will go to Middle East, and then to Africa, and then to maybe North, and maybe to Europe and North America, and so on and so forth. Let's say we have multiple programming teams, and let's say another programming team is working somewhere else but working on the same software. So they will be provided a namespace B, so that if they don't know that they have used, the other programming team have used integer a and b as their variable names, and it's essentially impossible whenever you have like thousands and maybe millions of variables. So it's hard to keep track that if they have used this variable name, then this team cannot use this variable name. So it's kind of difficult thing to do. So they would be allowed to use these variable names with no problem, because this thing, this thing is using namespace A, and this programmer team is using namespace B. So whenever all the program is compiled and all the software code is compiled, so if I'm talking about this variable, so this variable belongs to namespace A. So I'm going to write A colon colon A. So that means that this variable belongs to this namespace. And if I write B colon colon, sorry for bad writing, colon colon, and for example A, then that means that this integer belongs to this namespace. So that means that multiple programming teams and multiple software developers can use the same variable name, provided they are using a different namespace. And it also applies to the function names and object names and things like that. Okay, so a namespace is done, then new, it creates a new object and allocates memory, and let's say and it returns the address where that new object is created, and then we can just write directly to that memory location or access that memory location. But new does, whenever you want to create a new object, but you cannot maybe do not want to name this new object, but only want to access it through its memory location, you're going to use the new keyword. Not is, well, logical not. It will convert 1 to 0 and 0 to 1, or true to false and false to true. Then it will, and we have operator used to declare an operator overload. Probably not going to do that in our course. The OR operator is used to, is the logical OR operator, and it's equivalent to logical addition, or whenever one condition is true, the resultant result of that logical operation would be true. Then we have private. It is used to control the accessibility of the class members. I'm going to discuss that after midterm. Then protected, once again, is even more restrictive access to class members. Public is the most open declaration in a class. What class is? Essentially a definition of an object, and it's going to contain the variables as well as the associated functions, because object-oriented programming is more close to the real world scenarios which we encounter. Return, statement that terminates a function and returns a value, and such as return 0 or return some number or any value, whatever the function return type is. Short, integer type, it requires even less memory, maybe actually half as much memory as the normal integer. Signed is used, signed is not ready to use because that's the default type of an integer, because sign means it can contain positive as well as negative numbers. Sign character is behind the scenes actually an integer. Size of returns the number of bytes used by an object. Static, going to use that storage class of object that exists for the duration of the program. Whenever you want to keep that program in, or keep that function alive in the memory after its call, we're going to use that static sometime in later lectures. Static struct is a precursor to class definitions, so it is used to define some kind of a data structure, but it's not used that often these days because it is now being replaced by class definitions. Switch statement, whenever you have some logical statement, if this thing happens then do this, if this thing happens then do that, we're going to use a switch statement. This pointer that points to the current object might be used in linked list. You're going to do that in data structure course. True, once again, it's a Boolean type. Type definition declares assignment for an existing type, might be used sometime in later lecture. And then we have using namespace standard directive that allows omission of namespace prefix. So whenever we have using namespace standard, that means we do not need to write standard : before each stream modifier or wherever. I mean, the standard namespace contains cout and cn object definitions in terms of class definitions. Union is used with the structure. Unsigned means, I mean, whenever we have declared unsigned integer, that means it can only contain the positive values. Virtual, going to use that in class definitions whenever the time comes. Void means nothing, so that means that this function has a void here, as well as it's not accepting any argument, it's not returning any argument. Going to explain that later in some future lecture. Volatile, if you want to do that, declares object that can be modified outside of program control, but probably not a bright thing to do. Okay, while loop, going to use that. XOR is a logical operation, and there might be others, it's not an exhaustive list. Okay, standard C++ operators are this double colons, global scope resolution, also used for class scope resolution, and direct member selection. Let me erase that. Indirect member selection is pointing to something. It looks like an arrow. This is square brackets are used for arrow subscripts. You want to reference some, sorry, not arrow, array subscripts. You want to access some particular element in an array, going to use the square brackets. Function calls, well, you have to use the round brackets. Type construction, if you want to use that, once again, it's typecasting actually, so going to discuss that. Increment operator, decrement operator, silo operator. Once again, increment, there is something known as post increment and pre-increment operators. This bitwise complement, not going to use that, but it's useful sometime whenever you want to do some bitwise manipulation in some number or some memory space. Logical not, unary, plus, minus, I mean simple mathematical operators over here. This is a dereference operator. You're going to use that whenever we are using some pointers. Allocation, we have discussed that. New and delete, used to allocate a memory, deallocate the memory. Type conversion, such as this, it's actually typecasting. Direct member selection is a binary operator, useful in pointers whenever we are dealing with memory spaces. Indirect memory selection, used to access some memory location. Multiplication, division, and plus minus. I mean, there is something, and this is an address operator. You do not need to learn all these things. This is not the output and input operators. This is bit shift left and bit shift right, but here if you want to shift the, actually it's an overloaded operator. If you want to shift the number of bits to the left or right, you can use these operators, and you can also use this operator for output and input operators. This is a less than, this is less than or equal to, and you are essentially self-explanatory. X greater than y, so that means this expression, these are essentially logical expressions. And by logical expression we mean that let's say the value of x is 9 and the value of y is 10. So 9 is less than 10, that means this expression is going to return true or 1 which is logical 1 or true, and let's say 9 x value of x is 10 here in this scenario, and value of y is 5. X is less than n or equal to y, which is not correct. So that this expression is going to return false or 0. And here, if we want to check whether something is equal to something, we need to put two equal to sign, because the single equal to sign was used to assign a value of the expression to the left of that whatever the object name is. Not equal to, once again, a logical expression, bitwise and bitwise or, and this logical or, I'm going to use that a lot, and logical and we have to use double ampersand sign and double or signs. These are essentially long vertical bars. You want to they are usually on the key which has the backslash key. Your keyboard might differ. This is a conditional expression. I'm going to use that. This is an assignment operator. This is an assignment addition. This thing actually means n plus equals to 8 means it's a short form of writing n equals to n plus 8, and this is a short form of writing n equals to n minus 4. So we need to evaluate the expression and then assign the resultant value to the same variable, updating the value of that variable. Once again, n equals to n multiplied by minus 1 as in this case, and similarly this means n equals to n divided by 10. This thing means n equals to n percentage 10. This is not percentage, is actually a remainder operator. So let's say the value of n is 100, and if we divide 100 by 10, there will be no remainder, so n the value of n would now be 0. So the remainder value would be assigned to n, and let's say the value of n is 99, and if we divide 99 by 10, the remainder would be 9. That means that 9 is now assigned to n. I'm going to discuss that in examples in future lectures, so don't worry about it. This is bitwise and assignment. Bitwise operators are really not included in our course, so we can just leave that. This is bitwise shift left assignment. Once again, I'm going to use that. Comma is used to have multiple type of statements, something like that, just such as if you are declaring some variables, or such as integer a equals to 10 comma y equals to 5 and so on and so forth. We can use comma over there. There is one more thing over here, that there is something called overloadability. So if that operator is overloadable or not. Overloadable means that it can have different behavior depending on the context it is being used at that time. And here overloadability is actually a really advanced concept. I'm not so sure whether we are going to cover that in our course, because this is the first time we are teaching this course online, so I don't know your speed. So, well, overloadability, essentially it's the last or one of the last topics in our course, so or in the C++ course, so not so sure whether we're going to do that or not. The other thing is whether the operator is binary or unary operator. So let's say if we have a simple, let's pick a simple operator such as the plus sign. Over here, okay. Okay, so we have a plus sign addition, and it is a binary operator. It's also a unary operator. Going to discuss that in a moment. If we write m plus 10, that means it requires two operands to work. Okay, similarly this division is a binary operator. This percentage or remainder operator is also a binary operator. It requires two operands to act on. M divided by n. We cannot leave this thing as empty. Similarly, same thing with multiplication. And the associativity is left. Actually, we're going to discuss that whenever we are dealing with some mathematical operations. That the same rules of the bracket operations are done first, and the division multiplication are done first, and then addition and subtraction is done. But whenever we have the same level of precedence in a mathematical expression. Let's say we write 2 plus 4 plus 5 plus 10. So all of these operators have the same precedence. We haven't divided or multiplied anything. All of these things are addition. Then the things on the left are going to be evaluated first, and then it will go from left to right. Then we have something known as unary operators, and unary operators, they are, I mean, here, I mean, this is an address operator. It returns the address of this object which has a symbol X. Or similarly, we have this thing, and plus plus n is a pre-increment operator. Going to discuss that in the next lecture, what this means. It increments the value of n and updates the value of n. Let's say the value of n is 8. So if I write plus plus n, that means the value of n would be now 9. So it's also a unary operator. And let's pick another example, that let's say this thing, member selection operator. It looks like an arrow, so that means the P is now pointing towards this object, or the address of this object, as which has the name of LEN. That means that it's a binary operator. Similarly, if we have a function call, so it's neither binary nor a unary operator, because it's actually a function call. We are actually calling a block of code which has a name, and it might accept some values and might return some values. So this is a rand function which returns the random number between 0 and 1. And size of a, going to use that in the next lecture. It's also a unary operator because it returns the size of the object, in this case a. I mean, a could be any object. New and delete are also unary operators. And type convergence, well, they are binary because we need to have two types. I mean, if we want to convert character into integer. And then we have a, let's pick another example. Let's say over here, ampersand x is a unary operator because I think I've discussed that. New and delete are also unary operator because they are just making a new object of type P. P could be any type really, and they are returning an address wherever they have created the object in the memory space. Delete is deallocating that, so it's freeing up the memory over here. And some, you might have noticed that some variables are unary, some, and the sorry, not some variables, some operators are unary and some operator, and the same operators are then declared as binary. It depends on the context they are being used. So that means that they are actually overridable, and the same operator can perform different functions depending on which depending on which context they are being used.